In order to graph a quadratic, the first thing, and really the main thing we need to know, is the vertex. Okay, so we need to be able to find the vertex. Okay, now the way we find the vertex is going to be in two steps. The first step is finding the x value. Okay, the x value of the vertex is going to be negative b over 2a. So what does that mean? If we have a quadratic function, it's going to be ax squared plus bx plus c equals y, or y equals, either one is fine. Okay, so if we have negative b over 2a, it means we're taking the coefficient of our linear term and putting it, making that negative and putting over twice the coefficient of our quadratic term. Okay, so what does that mean in the context of y equals 2x squared minus 4x plus 3. Let's identify what a, b, and c are. A is 2. B is negative 4. And C is 3. Okay, 2, negative 4, 3. In order to find the x value of this vertex, we need to find negative b over 2a. So if b is negative 4, it means negative b, that's negative negative, it's positive 4. You know the x value is going to be 4 over 2 times 2. We'll see it as negative negative 4 over 2 times 2. So this is 4 over 4, and that equals 1. Okay, so the x value of our vertex is 1. So our vertex is going to be 1 something. So that's the x value, negative b over 2a. Okay, the y value equals f of negative b over 2a. All this means is plug the x value into the equation. Plug the x value into the equation. So going back to our example, all we're going to be doing is plugging 1 into our equation. So y equals 2 times 1 squared minus 4 times 1 plus 3. Okay, so 2 minus 4 plus 3, that equals 1. Okay, that equals 1. So we have a vertex of 1, 1. Once we go from there, once we have that, we can plot our points, plot our vertex, and go from there. Okay, so let's go ahead and do that. We have our vertex of 1, 1. Let's set up our graph. Okay, so we have a vertex of 1, 1. Okay, from here, we're going to go back to our table. A simple XY T chart. Okay, XY T chart. We're going to pick values for x that are close to 1. In this case, because the x value of our vertex is 1. And we're just going to pick it on one side. So let's go with 2, 3, 4. That should be plenty. Okay. So the y value, we're just plugging this back into our equation of 2x squared minus 4x plus 3. So f of 2, we plug that in, gives us 8 minus 8. That gives us 3. Okay. So the point 2, 3. Okay. We plug in 3. Okay. let's see, that's 18 minus 12 plus 3. That gives us 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I don't think 4 is really going to show up on this page. F of 4, let's see, 16, 32 minus 16 is 16 plus 3 is 19. Okay. So that doesn't show up. Now, the reason we only picked values on one side of our vertex is because of our line of symmetry. Okay. It's our line of symmetry here. Since we're 1 to the right and 2 up, this point, we're now going to be 1 to the left and 2 up. Since we're 2 to the right and 8 up here, we're going to be 2 to the right and 8 up over here. Okay. Our line of symmetry is exactly that. It's the same on either side. So now we connect our points. And we have a parabola. Okay. I threw a lot of information here at you. We're going to do another example together. Okay. Another example here. But the big things we need to know is that finding the x and y values, negative b over 2a, and plug that value back into the equation. I guess we need to know a, b, and c as well in order to be able to do this. Okay. Let's try another function. This time we have y equals x squared plus 6x plus 6. Okay. Where a equals 1, b equals 6, and c equals 6. So let's find the x value of our vertex. X equals, remember, negative b over 2a. So in this case, that's negative 6 over 2 times 1. That equals negative 3. Negative 3. We're going to plug that in for y. Y equals f of negative 3. So that's negative 3 squared plus 6 times negative 3 plus 6. So it's 9 minus 18 plus 6. That equals negative 3. So we have the ordered pair negative 3 as our vertex. Okay. Now that we have that, let's set up our table. Let's set up this table anywhere. Let's go right up here. And we want to pick values that are close to our x value in the vertex. So close to negative 3, we'll be on one side. I'm going to go towards 0, negative 2, negative 1, 0. Okay. Let's see. F of negative 2 is 4 minus 12 plus 6. That's negative 2. Okay. F of negative 1. That's 1 minus 6 plus 6. That's 1. F of 0. That's 0 plus 0 plus 6. That's 6. So we have the point 3, 3, negative 3, negative 3. Okay. We have the point negative 2, negative 2. With the point of negative 1, 1. The point of 0, 6. I did a bad job again of setting up my axes, but look at the point. We have that line of symmetry still, the axis of symmetry. So we know how far up and to the right it is It's gonna be that far into the left. So -4, -2, -5, -1, -6, 6. I'm just gonna go straight through. We have another parabola. Okay. I'm gonna have you do one more on your own. I want you to tell me what the x value is, what the y value is, and then I want you to pick out a graph. Okay. All right. I want you to try y equals 1/2 x squared minus 2x minus 1. Okay. First, tell me what A, B, and C are. Should have gotten 1/2, -2, -1. Next, I want you to tell me what the x value of our vertex is. Where's -b over 2a. So what does x equal? We should have gotten 2 over 2 times 1/2. So that's just 2. Now I want you to tell me what the y value is. So the vertex of 2, -3. Let's start our table. We want values that are close to 2, right? X, Y. So I'm going to go, we can either go to the right or to the left. We've gone right the last 2 times. Let's go left this time. We're going to go 1, 0, -1. So just find f of 1, f of 0, f of -1. So we got -2.5, -1, and 1.5. Let's graph it. And this is what we can do together. Okay. With the point 2, -3, 1, -2.5. Man, I messed up, guys. Graphing, I've been struggling with graphing today. 2, -3, 1, -2.5, 0, -1, -1, 1.5. Okay. We have our line of symmetry. So we do the same thing on the other side. 3, -2.5, 4, -1, 5, 1.5.